Good afternoon once again. Good afternoon once again. I welcome you to today's Threat Intelligence Seminar. I'm Daniela Pinin. I'm your host for today's session. Before we get into the real deal, we are going to have our usual security awareness training. And then from there, we answer some few questions before our resource person comes to play. So without further ado, I'm going to play the video and then we proceed. Thank you.
Global shipping and mailing service Pitney Bowes recently suffered a ransomware attack that shut down key services, costing the company millions of dollars in losses.
France was fun, but I gotta say, it is good to be home. Oh, man. Gross. Nico, buddy, is that you? Oh, great, you're here. Wait till you see what I brought you. Well, huh? Look at this. Ain't it the most beautiful thing you ever laid your eyes on? A charging cable. Correction, not just any old charging cable, my friend. This is the OMG cable. And watch what this puppy can do. Wait a minute. A charging cable that infects computers with malware? Yeah, any old hacker can just buy them off the internet. You just plug it in, and voila, instant ransomware. It's pretty great, right? Oh, Nico, the wheels are turning. Huh? What's going on inside that criminal mind of yours? We need to get some of these into the Brittany Post conference room ASAP. I've been wanting to target them for a ransomware attack for a long time now. And this might be the perfect way to do it. They have online systems we can take down that'll cost them millions of dollars in losses every day. They'll be begging us to pay a ransom to set their systems free. Just one problem. How do we get these OMG cables inside their offices? Whoa, hold on. I have an idea. Into the Brittany Post conference room. Who's the biggest swag company on the planet? Swag Masters, of course. Of course. We send 10 of these cables as sample swag, disguised so they appear to come from Swag Masters. We send them to their VP of sales with instructions to leave them in the conference room for their sales reps as gifts. First one to take the bait, bam, lock screen. After that, their entire network is impacted. We are back, baby.
We've notified the FBI and we've brought in ransomware specialists to try and eradicate the problem, but it hasn't done any good. We've spent 3 days on this and have lost millions.
I think it's time for us to implement our full business continuity plan. Wipe everything clean and restore from backup. It'll be painful, but we are not going to pay the hackers. Also, please put out a notification letting people know the only phone chargers they use should be from a known and trusted source, such as those purchased directly from where they bought their phones. Or if they purchase phone chargers online, they should use only genuine manufacturer products.
Got it. I'll get that out immediately.
For the sake of the people that just joined, I'm going to play the video one more time and then we answer the questions when I'm done.
Global shipping and mailing service Pitney Bowes recently suffered a ransomware attack that shut down key services, costing the company millions of dollars in losses.
France was fun, but I gotta say, it is good to be home. Oh, man. Gross.
Nico, buddy, is that you? Oh, great, you're here. Wait till you see what I brought you. Well, huh? Look at this. Ain't it the most beautiful thing you've laid your eyes on?
A charging cable.
Correction. Not just any old charging cable, my friend. This is the OMG cable. And watch what this puppy can do.
Wait a minute. A charging cable that infects computers with malware?
Yeah, any old hacker can just buy them off the internet. You just plug it in, and voila, instant ransomware. It's pretty great, right? Oh, Nico, the wheels are turning. Huh? What's going on inside that criminal mind of yours?
We need to get some of these into the Brittany Post conference room ASAP. I've been wanting to target them for a ransomware attack for a long time now, and this might be the perfect way to do it. They have online systems we can take down that'll cost them millions of dollars in losses every day. They'll be begging us to pay a ransom to set their systems free. Just one problem. How do we get these OMG cables inside their offices?
Whoa, hold on. I have an idea. Who's the biggest swag company on the planet?
Swag Masters, of course.
Of course. We send 10 of these cables as sample swag, disguised so they appear to come from Swag Masters. We send them to their VP of sales with instructions to leave them in the conference room for their sales reps as gifts. First one to take the bait, bam, lock screen.
After that, their entire network is impacted.
We are back, baby.
We've notified the FBI and we've brought in ransomware specialists to try and eradicate the problem, but it hasn't done any good. We've spent 3 days on this and have lost millions.
I think it's time for us to implement our full business continuity plan. Wipe everything clean and restore from backup. It will be painful, but we are not going to pay the hackers. Also, please put out a notification letting people know the only phone chargers they use should be from a known and trusted source, such as those purchased directly from where they bought their phones. Or if they purchase phone chargers online, they should use only genuine manufacturer products.
Got it. I'll get that out immediately.
Okay, welcome back from watching the video. Now, we're going to answer the questions before the resource person takes over. So I'll read the questions, and then if you have any submission, we take it from there. Okay, so the plug and pay ransomware first. The first question reads, can you trust in a USB phone charging cable bought by someone else? Option 1 says yes, option B says no. Anybody?
No.
No. Okay. Question 2 reads, which of the following statements regarding these malicious charging cables is true? The first option says they look just like a legitimate charging cable. B says they hide a backdoor inside the shell of the USB connector. C says they can act as a Wi-Fi microcontroller. D says they are called OMG cables. And the E says all of the above statements are true.
I'll say all of the above statements are true.
Okay. Any other submission? or we should go with that? Anyone with a different submission? Or that's all we've agreed? Okay. Question 3 reads, true or false? Hackers can install malware on your device through a modified USB charging cable. True or false?
True.
True. Okay. The last question reads, what is the best way to ensure that your charging cable is safe? A, by asking a friend to take a look at it. B, by purchasing the cable yourself from a known and trusted source. C, by plugging it into your device. And D, by checking if the cable uses the same USB type as your device.
B.
Pardon?
B, the second option.
So mean by purchasing the cable yourself from a known and trusted source. Do we all agree? Please, do we all agree? That is B.
Yes, I agree.
Okay, cool. All right. So let's complete the quiz. See where we are. Okay, we got 100. And yeah, so that is it for our securities awareness training video. Okay, so before we get into it, our resource person for today is Thomas Ntompe, and he will be taking us through cloud computing and virtualization. So Thomas, if you are here, the floor is yours. Thank you.
Okay. Hello, can you hear me?
Yes, we can.
Okay, let me share my screen. I'm coming. So, hello, can you see the screen?
Thomas, we can see your screen. Let's proceed.
Okay. So, hello, everyone. Thank you for joining us today. As Daniela said, I'm Thomas, and I'll be presenting on the topic virtualization and cloud computing. So, let's say you're an organization or a business, and then you can imagine that you have digital resources that can grow when you need it to be, that has the ability to adapt to changing business needs without any disruptions. This kind of service that you can get from cloud computing, even when disaster strike, you still have these resources intact, as cloud computing is a major player in modern day technology, as many businesses and organizations use cloud computing in their day-to-day activities. With cloud computing and virtualization, individuals or an organization can actually access and use computing resources whenever they need them without having to actually buy expensive hardware or handle maintenance. Cloud computing and virtualization is actually adaptable and cost-efficient solution for today's IT needs. So whether it's for storing large amounts of data, running complex applications, or ensuring business continuity, cloud computing and virtualization is there for you. So today, that's what you'll be looking at. So in this presentation, we will actually explore the details of cloud computing and virtualization. We will also look at some advantages of cloud computing and virtualization, challenges of cloud computing and virtualization, and also innovative ways that these new systems or that these systems are shaping the future of technology. So you might wonder, what is cloud computing? So if you actually check online on various different sites, you actually realize that there are thousands of different definitions of what the cloud might actually mean. A friend of mine told me that cloud computing refers to computing devices that are simply located off-site from where you happen to be. Yeah, even though that definition is correct, cloud computing has many more capabilities than that. In my own understanding, cloud computing refers to servers that are accessed over the internet and the software and databases that run on those servers. So let me break it down. So let's say you're an organization or you're a startup company or you want to set up a company for the first time. Now you have to actually find capital or money to actually buy tech infrastructure. You have to actually find databases to store your data. If you want to publish an application to manage your organization, or let's say to actually perform services, you need to actually find developers or programmers to actually, sit down and create this idea from the scratch. If let's say you want to use web applications, you have to actually purchase a server to actually facilitate this process and other things. And maintaining all these things is another cost mechanism, because you actually need more money or extra money to actually maintain all these services. But cloud computing actually gives you all these things. Cloud computing can actually give you the ability to store data digitally, can give you the ability to run your application or software platform to actually enhance your operation or your business. It can actually give you a virtual desktop and also servers for actually running your application without the need to act physically or without the need to buy the hardware itself, because the hardwares are costly. You just need to pay a small amount of money for the services that you may need. And since your organization is starting up, you can actually purchase, let's say, the kind of service you need at a low price. And as you expand, and as you get money, and as you get more capital, you can actually expand this cloud computing service, because that's how cloud computing operates. It comes from the system pay as you go. You pay what you need or you pay what you use. So there's no need for an extra cost to actually go and buy a big server sitting somewhere that you might actually not need. And I'm not saying that you don't actually need a server or you don't actually need a physical location to actually keep or to actually manage your business. You can have physical, let's say, hardware or a computer station or a supercomputer somewhere, but you can also allocate some of your processes to cloud computing. So if we look on the diagram on the screen, you can see that different computers are connected to the cloud. And within the cloud, you have servers, virtual desktop, software platform, application, and then storage data. So this is what cloud architecture gives people. And then you can connect anywhere, everywhere, wherever you are, as long as you have the internet. You can be sitting at the office, as long as you have, hello? Please, is somebody saying something? Can I continue?
No, we can continue.
Okay. So as long as you have the access to the internet, you can access your cloud, your applications, and your data and your files from this cloud component. So let's say you actually lose your phone and then you buy a new one. Now, if you try and log into, let's say, your Instagram account, you actually realize that you have your old conversations, you have your pictures, you have your video that you took with your previous phone, all in the account, because Instagram actually uses this cloud computing architecture So as long as you have your login details, you can actually access your Instagram account from anywhere on any other devices you choose to. And that's how cloud works. Also, your Gmail account, your mail account. If you log into a different laptop or a different phone, you realize that all your previous mails are still intact. Everything is still there. You don't have to worry about where your messages or where your email will go. The attachments people sent you, they will all be in the email. You don't need to actually worry about maintaining, let's say, your email service, thinking about what will happen to it is not what you are looking for. What you care is you log into your email, you have your messages, you have your attachments, you have everything there. And that is what cloud computing actually offers. So, like I said, cloud computing, as long as you have internet, you can access it. You don't need to actually go and buy the hardware equipment. As long as you have cloud computing, you don't actually need to buy all those systems. You can simply pay for the service the cloud will give you, because different companies are all tapping from this same cloud system. So company A will pay, let's say, $100 for a particular portion. Company B will also pay for $2,000 for a different portion, depending on each organization's strength and needs. So at the end of the day, you realize that all of you are coming together to actually maintain or to actually provide for the data centers. Now, the data centers are where the servers are. So the cloud service providers like, let's say, Microsoft or Google has a very large data center somewhere all across the world. And as if you employ Google services from Google Cloud, you have access to this data center, and different companies all over the world has access to this Google Cloud. So you pay for the portion you need, another company pays for the portion another company also needs. You don't have to worry about how Google will maintain the data. You don't have to worry about the security and other things. You just think about your data, your files, and your information. Virtualization. So virtualization is also another component, because without virtualization, there won't be, let me say, cloud computing. Now, what is virtualization? So virtualization is a process that allows a computer to share its hardware resources with multiple digitally separated environments. So let's say if you have a supercomputer with large terabytes of storage capacity, the RAM of, let's say, 512 gig, and a very huge processing power for that supercomputer. Now you can actually divide that supercomputer into sections for different people. Okay, using, let's say, a software or using a system. So with this supercomputer, let's say you're an organization and then you have one big supercomputer, but you have lots of staff, lots of workers, and you want all of them to be connected to this supercomputer. All you need is just to have a software on this supercomputer and allocate the space on the supercomputer to individual workers. So each individual worker will have a different portion, or have a portion of, let's say, the hardware components, such as the processors, the memories, the storage. So let's say the supercomputer has 8 terabytes. You just give maybe worker A 100 gig of storage, 18 gig of RAM, because the RAM is too big. You give same to worker B, you give same to worker C, you give same to worker D. Now, these individual workers do not know which other person is on that same supercomputer, because you are using yours separately, and it treats worker A's platform as a full computer on its own with the allocated space. Worker B also the same, worker C also the same. So with virtualizations, you can actually switch to different operating systems from one different server. So with that same supercomputer, worker A will have, let's say, a Windows with dedicated portion. Worker B will have, let's say, a Linux with another portion. So that's how virtualization actually works. Okay, so virtualization is more of a standard practice in today's IT architecture. You have something called virtual machines and hypervisors. So the virtual machines are actually the virtual environment. Okay, so the virtual machines are like, let's say, your personal PC. Okay, so your PC there, and then you put an app on the PC. You put an app on the PC. Now, when you open that app, the app, or when you open that software, it gives you a new operating system with different, like I said, different space and processing power. Okay, so that's what the virtual machines are actually are, the VMs. Okay, so it's just more like software, comes in a software form, and once you're an organization, you install that software on your laptop. Now it becomes a virtual machine. Whatever you do in that virtual machine stays in that virtual machine. Okay. Okay. So, and then we also have something called hypervisors. So with the hypervisors, it manages multiple virtual machines on the computer. So the supercomputer will have an hypervisor on it, or the supercomputer might actually be an hypervisor. Then different virtual machines are actually connected to this hypervisor. So this hypervisor will actually apportion different storage units or processing units for the virtual machines. So the hypervisor makes sure that these virtual machines don't actually interfere with each other. So whatever you do on your virtual machine stays on your virtual machine. The reason why the hypervisor was actually created to manage the virtual machine. So that hypervisor kind of creates, let's say, a block between each virtual machine, making sure that you don't actually whatever you do in one virtual machine don't actually skip or enters into somebody else's virtual machine, because in cybersecurity, the integrity, confidentiality of data is very, very important. So the hypervisor maintains all these things. Now, we look at some benefits of cloud computing. What makes cloud computing, beneficial? Because the first one is on-demand self-servicing computing. With cloud computing, you just have the resources available to you where and whenever you need them. So you as a company, you can actually go there and just go to, let's say, Google Cloud and say you want 10 gig percent or 10 gig worth of Google services. Okay, so it's self-service because you can actually go there and actually do everything yourself. If you need more space, you can actually click that you need more space for your services or for your business, and you will get it wherever you are, what time or where or when you actually get cloud computing or cloud computing services, sorry. The second part is scalability. So let's say if you're an organization or if you're a person, and then your demand, the demand for your cloud-based service or your demand for the service that you've purchased from cloud it's increasing. Now you have the power to actually increase the capacity to meet the number of people who are connecting. So you have a company, you have a server whereby different people are actually connecting, different people are, you are expanding your data, your consumer base or your database, and then you need more data. You don't have, you need more, let's say, services or more platform to actually handle this growing need. Because people are joining in your staff, you are getting more staff, you are expanding your business operations. With cloud computing, you just have to actually go to the service provider or the cloud service provider and tell them that, hey, I have this, I need this amount of space, I need the amount of services to add to the already existing service that I have. They'll be like, fine, take it and use it with the budget that you have, so you can actually purchase more. So when you are actually done, you can actually tell them that I don't need this service anymore. They'll be like, oh, that's fine. Use the one that you need, and then the rest we can apportion it to somebody else. So with cloud computing, you just have that flexibility, that kind of ability to expand wherever you need the services. So elasticity and scalability are somehow related. So with elasticity, like I said, you have the capacity to expand and contract as your need change. So if you realize that, yes, you need more services, you expand. You realize that right now you're not getting more service, you're not making more use of the cloud, and you want to actually decrease your services, you can actually do that to optimize costs. Okay, that's the elasticity. And then the measured service. So everything that you do with cloud is measured by the cloud service provider. So the cloud service provider track the number of seconds or the number of second processing time you consume, the amount of storage you occupy, the number of log entry that you generate, and many other things. So you are billed based on how you use the cloud services. Like something that you buy, and even if you don't use it, you are still getting paid for. That's not how it works. You pay what you use, or you pay for exactly what you use, no more, no less. So the last one is agility and then flexibility. So it's agile because you can use them for a short period of time, like as you need it. And based on your budget, you can actually use them for, let's say, 1 day or 1 week. Probably you are setting up a new application and you want to find out how it will react with cloud environment or cloud system. You can just go to a cloud service provider and tell them that, oh, you need a day worth of cloud, let's say, service, because you need to test something out. You need to test how this environment or this new app that you are developing will react with cloud environment. You can just go there, test it out, evaluate the approach, and decide whether to move into production of that application with the cloud service that you want, with minimal effort and cost. So cloud computing offers or gives you all these benefits at hand, and is actually mostly preferred over the traditional method of buying the hardwares, buying all those storage devices sitting somewhere that you might not actually need them because you are now setting up. We look at types of cloud computing. So cloud computing can actually be divided into two main components. So cloud computing based on deployment, based on how it is deployed. And then we have cloud computing based on the service module. So how, or based on how it is deployed is there. Then based on the services it provides, so is there. So we will look at the first kind of group that is based on the deployment. That is the private cloud. So now the private and the public. So whenever you hear about cloud, you think about the public one, because the public one is whereby any organization. Any organization can just go to, let's say, Google or Amazon Web Services and tell them that I need this amount of space. I need this storage you need. Give me this, give me that, give me this amount, give me that amount. So organizations can actually go to the service, the cloud service providers, which are the Googles, the IBMs, and the Microsofts, that you want this CPU cycles, you want this storage, you want this bandwidth. That is the cloud that we mostly hear of, or we mostly get to know whenever somebody say cloud computing. That's what comes to our head. So you can actually, let's say Google Drive, you have the amount of space on Google Drive. So that becomes a public cloud because different organizations or different people can actually access Google Drive. As long as you have a Google account, if you want to buy for extra portion, you buy for extra portion. But the Google Drive becomes a public cloud. Now we have private cloud. So some organizations don't want to, let's say, go to Google for cloud services. They want to purchase their own supercomputer, their own equipment, and build their own cloud within its own data center. So this is referred to as the private cloud because it is the one that only the company has access to, and it's not designed to be shared with anyone else. Okay, so in private cloud, the computing services are actually managed by the organization it was designed for. So let's say if you have a big organization, you have established yourself, and you don't want to use public cloud no more. You want to actually create your own cloud to, let's say, save your data or to store your data or to run operations. So you go and buy that equipment solely for the company. No one else has access to the cloud, and will be within the confines of your, let's say, the organization. So anybody else outside the organization, you can't access this kind of private cloud. It's not accessible to anyone. And with that, the organization actually manages the security, the customization, whatever you want, because it is meant for you. It is all designed for only the company uses. Unlike the public cloud where you go and buy it or you go and buy the services from somebody else. The third one is the hybrid cloud. So the hybrid combines both the both the private and the public cloud features. So let's
Hello?
hello, can you hear me?
Yeah, I can hear you now.
Okay, sorry. Okay, so I was talking about the hybrid cloud, whereby it uses both the private and the public. Okay, so here, when there's a demand, so the company already had the private cloud already in its company, but then when the demand for the computing and the processes fluctuates, the hybrid cloud, the companies actually employ public cloud systems to actually add onto their already existing private, okay, to make sure that they can handle overflow. Okay, so it's not that they are just migrating, they are just using the services of the public cloud for a while. So when that demand goes down, you can actually, let's say, take it out or take it off. Okay, so these are the types of cloud based on deployment. You have the private, the public, and then the hybrid. And then based on service modules, we have three. So we have the infrastructure as a service, the platform as a service, the software as a service. The first one, which is the infrastructure as a service. So there may be times where an organization has built their own application. but then they need a place to actually run it. Okay, so with this application that this company has actually built, it includes database, web servers, and other devices. They just need raw infrastructure to be able to load the software and publish this software in this cloud instance. Probably maybe because they want to reach different people from different countries or across the world, they might actually employ cloud services in its operation. So that's what we term as infrastructure as a service. So the cloud service provider is only giving them, let's say, a few things. It's only giving them, let's say, the building block, the fundamentals needed to actually build a website or needed to actually publish a website. Okay, this is also termed as, let's say, hardware as a service, because you are just buying time on somebody else's hardware and then deploying your own software to that particular deployment. So you are just buying the hardware digitally. So you just need the infrastructure that somebody else has already built. And then you buy that thing. So let's say the CPU or the storage or the network, that's only the things you need. The rest will be managed by you. Anything else will be managed by you. That is that type of cloud. That is called infrastructure as a service. Okay. The next one is software as a service. Now, with software as a service, or SaaS, the end user don't have to deal with anything relating to the application or the operating system. Here, you just use the software to do whatever you want to do. You can just log into the software and do whatever you want to do. So let's say Gmail, if you're in a company and then use Gmail for your services, you just have to log into Gmail and then use Gmail as you like. Here, Gmail becomes software as a service, because you, the end user, you don't have to actually worry about building the application. You don't actually have to worry about the deployment on an application, the management, the updates. All you have to do is that you know that once you go to Gmail, everything already be set for you to use. So with this, you don't also have to worry about how to save the data or how you protect the data. So the software as a service provider, which let's say is Google, whenever you log into your Gmail, is responsible for all these things. It's the one responsible for maintaining the application, storing the data, and keeping all that information safe. So all you are doing is just simply logging onto a website and using the application. This is called software as a service. You just need your username and your password, and then now you have an entire system available to you. You don't have to worry about any other thing. Google's handle all the rest. So another example is Microsoft 365. So let's say if you open Word or spreadsheet and you do something and you save it with Microsoft 365, you don't actually care whatever happens to the file, because you know that the responsibility of Microsoft to actually keep your Word file or your spreadsheet file. Once you log on with your computer and open Word, you can actually click on your document and it will bring it. That's software as a service. Then we have the last one, which is more like the middle ground between infrastructure as a service and software as a service, which is the platform as a service. With platform as a service, somebody else is actually providing you with the platform and you can actually use to build your own applications. So you wouldn't actually need to worry about other things, let's say the infrastructure, the hardware, and other things. But then you have to actually build your own application. So the platform as a service provider will just give you everything and then just give you your logins to enter and create your own application. So let me use this WordPress, for example. Probably if you go to some websites, you see that powered by WordPress. So once you get a WordPress account, you just have to log into WordPress and then create your own blog, or let's say website, how you like it. So sometimes when you enter your WordPress account, they might give you even templates. They might give you modules to work around to be able to actually create your blog or your website. But then you as the company must actually tweak and use or make your own application to actually meet your own needs. You don't have to worry about the underlying infrastructure, that is the network, the servers, the operating system, the storage. You just have the control over the app that you deploy, let's say the website. So if you create a blog with WordPress, you only care about, or you only have access or control to that.
Hello? Can anyone hear him? Because I can't hear him.
Nah. Oh, I can't hear him also.
Oh, okay. I thought it was coming from my end.
Yeah, hello.
Okay, yeah, you are now on here. It went off a while.
Where was the last part that I reached before I went off? Because I didn't see it from my end here. What was I talking about before I ended on your side? If anyone can tell.
Before you came to this page, just
Yeah.
10 seconds.
Before I
Yeah,
came to
just yeah. Some 10 seconds. You went off like 10
So
seconds.
10 seconds. So to you guys, I did the private cloud, the public cloud, and the hybrid
Okay,
cloud.
so I
Okay.
think you
Yeah.
were still on, you're on the platform as a service.
Platform as a service. Okay. Okay, so platform as a service. Okay, sorry about that. So platform as a service is more like the middle ground between infrastructure as a service and software as a service. And then I was using WordPress as an example. So if you want to actually build a website and then you don't know how to, WordPress is more like a platform as a service whereby you log onto, you create an account, and then you create your own website. The website will be powered by WordPress though, but you just have to care about website and the data and all. You just don't worry about the underlying infrastructure. WordPress has the obligation to actually maintain the security, to actually maintain the network, the operating system for your website. Okay, so with platform as a service, you don't actually need, you actually need the infrastructure and you actually also need the software. But here you are doing the software on your own. So it's more like a blend between the infrastructure as a service and then the software as a service. Okay, so sometimes if you go to, let's say, WordPress, they have templates, or let me say Canva, whereby people used to create, let's say, PowerPoint designs and then graphic designs. Once you click on Canva and then you log into Canva, your designs are still there. Then Canva also offers you the template to use, so you can actually tweak and use any PowerPoint presentation that you want at Canva. And Canva is responsible for saving, for maintaining, for doing any other things. What you care about is the design that you made. So that becomes platform as a service. You're just using the platform to actually do your business. But here you have to actually create create it to meet your needs, how you want to use this platform. So these are the three types of cloud computing services based on its service modules: infrastructure as a service, platform as a service, software as a service. Now we're looking at the uses of cloud. What are cloud used for? So the first one is scalable infrastructure. So like I said, it enables organizations to actually open up their computer resources based on demand without needing to actually buy physical hardware. So the more demand you get, the more you expand with cloud computing. You don't need to actually go in and buy physical hardware. Unlike, let's say, if you have a storage unit in your computer and then the computer storage unit is full, you have to actually go and buy an external hard disk, or you have to actually go and buy a bigger hard disk or bigger SSD. But with cloud computing, you can just, with one click, and just get more space, get more services from your cloud service provider. So the more you need it, the more you actually buy it. If you don't need it, you don't buy it. You just buy what you need. Okay. The next one is disaster recovery. So most people use cloud services as their backups. Okay, so whenever there's a disaster, whenever something happens to, let's say, their physical service. So a company has its own hardware, its own services somewhere, and then there's blackout or there is this natural disaster like a tornado, and it takes the company out. It takes the service of the company, infrastructure of the company out. You can actually rely on the cloud services because it's a cloud. You can access it anywhere as long as you have your login. You don't need to worry about other things. So people actually use cloud. People actually use cloud as backup recovery to their system. So as long as when you have a disaster, as long as you have your cloud settings, everything intact, you can actually use the cloud for quick recovery in case of system failures and disasters. So another use of cloud computing is data analytics. So since cloud can actually facilitate big data, can facilitate large volumes of data, organization uses this to actually process and derive insights. So like I said, it uses data centers, the cloud storage. So Google has its data center somewhere, and then you go and pay for the services of how much you need that data center, or the kind of, let's say, size or capacity you need that data center. So organization can actually use cloud services for data analytics because it is fast. You get it done, unlike, let's say, traditional software, traditional hardware system that sometimes it is mathematically intensive for the CPUs and other things. So with cloud services, people actually use it for data analytics. And then we have streamlined software access. So with cloud computing, you just need it based on, let's say, a subscription-based access. So if you are using Google Drive, okay, you just subscribe to it over the internet. You don't actually care about the hardware. You don't actually need to go and invest into hardware to actually maintain your Google Drive. Or let's say if you deploy an application, or if you deploy a website using WordPress or any hosting application or any hosting platform, all you care about is your software access. So the platform will charge you, let's say, if you publish your website for 2 years, we are charging you this amount of money. So you as an organization, actually, let's say I'll go, let's say, 4 years for this amount of money. Then you deploy or you publish your website using that platform. Now, anybody else can access that platform anywhere. You can also, as a company, access your platform anywhere as long as you have data. And that is what the streamlined software access. You have access to your software anywhere, anytime, as long as you have subscriptions in place. Then the last one is efficient application development. So as a company, if you want to, let's say, deploy an app using cloud services, it's not that difficult. Okay, because like I said, the platform as a service will give you all the building blocks and what you need to actually build an app. So once you are building an app, all the tools, all the environments, and any other things is made simple for you. So you can actually use it to actually deploy any app or to develop any application that you want using that service provider. So it makes development of application efficient and easy. So you don't actually have to know how to code to actually make the application over that service. You go to the services, there are a lot of modules and templates there. You just look at the template, which one that meets your need, can actually tweak it to how you like it, and then publish it. So it makes development of web application simple. Then we also have disadvantages of cloud computing. So we have security risk, internet connection dependency, downtime and reliability, and then unpredictable costs. So with security, now as cybersecurity professionals, security is your utmost concern. Okay, and then with this, it means that if you actually employ the services of a cloud service provider, whenever the cloud service provider, let's say, is hacked or faces security challenge, you get scared about your data because they are responsible for managing your data. So whenever the company suffers a compromise, your data might actually be compromised as well. So that is one thing about cloud computing, even though people say, yes, cloud computing is actually secure because the hackers are not actually hacking the company itself. The hackers are actually targeting let's say, the cloud service provider, which is Google or Microsoft. So if Microsoft is compromised, the hackers actually are able to actually compromise or hack into the systems of Microsoft or Google. It means that your data or your system, the system that you operate on with Google can also be compromised. And also, there is this lack of transparency regarding how and where sensitive information that you give to, let's say, your service provider is handled. Okay, you don't know what they do with the information. You just know maybe they are protecting it for you. Maybe they are using your data for something else. How will you know that the data that you are giving to them on their cloud, the cloud platform, they're actually accessing your data, they're actually reading your data for something else? You don't know. So the security risk becomes a disadvantage of cloud computing. Then you also have internet connection dependency. So you need internet to actually access your cloud. So without your internet, you can't access the cloud. It's simple like that. So if you are in a place where the internet is not fast or the internet is slow, it means that you can actually access a cloud-based system or cloud-based service. Unlike the traditional whereby you have the physical hardware close to you or next to you, whenever you need it, you go to that place and then you access it. So if your internet connection is not actually strong or you don't have internet connection at all, there is no way you can actually use cloud-based system. And also, let's say you try connecting cloud-based system with the public Wi-Fi. Once you connect with the public Wi-Fi, you are opening that system to attacks, or you are posing, it poses a threat because hackers can actually use public Wi-Fi's to actually infiltrate the system. So with cloud computing, since it uses internet and then internet connection, if you actually log onto a public Wi-Fi, let's say thinking that, oh, let me access my data using this public Wi-Fi for a short time, you might not know what some hacker is actually tracking you or trying to actually infiltrate your system using that time that you are connecting to the cloud system. So that becomes a disadvantage. We also have downtime and then reliability. So even though cloud services are actually dependable, they may sometimes have interruptions and downtimes. Because let's say if Google or Microsoft is trying to maintain its service, or let's say there's maintenance, it might actually disrupt your service because you depend on Google to run your business, or you depend on this app to run your business, and then this app says they are maintaining, or they are doing a maintenance check, or they are doing something with their system. So maybe your services will be down, or the speed that you bought with us will be down for, let's say, for some minutes. But you too, as a business, you need your system to be on 24/7 so that people can actually access it. This becomes an issue with cloud computing. And let me make a reference with the traditional system. You have your own server, it is there. You are the person responsible for maintaining it. So if you want to maintain it, you actually tell your employees and your customers that you want to maintain the system. So sometimes we get alerts from service providers, can be internet service providers, that our systems may be down because we are doing this and that checks on our system. But then with cloud computing, you can't actually, they are not reliable in some extent because they can also have these challenges. Okay, sometimes too, the cloud service providers may be overwhelmed with the number of clients that they provide services to. Since different companies and different individuals tap into, let's say, the service providers cloud platform, sometimes they get overwhelmed, and then this can lead to technical outages because different people are and different organizations are actually connected to this cloud-based system. So when a lot of people, a lot of organizations, a lot of people are accessing this cloud system at a time, sometimes it can go down temporarily because they are overwhelmed by this kind of, let's say, circumstance. And then once you deploy an app through this cloud-based system, once this goes down, I mean your app also goes down. Okay. And then the last one for the day is unpredictable costs. Okay, so in cloud computing, costs can be difficult to predict due to, let's say, pay as you go subscription plan, and then the need to scale resources for different workload demands. So this means that you only pay for what you use, like I said, but then some months you can use more services because more workloads and more things are, let's say, coming to your system. So you can't actually allocate a budget to your cloud computing services because if you need more, you have to actually buy more to work. So this brings unpredictable costs to you as an organization. You can't actually know how much you spend on cloud computing services, unlike, let's say, the traditional one whereby you bought a system. You know, this system costs $5,000. So this system costs $5,000. Maintaining it costs $1,000. This is how much we are going to invest in this, let's say, system or in this hardware. But with the cloud computing, the cost goes up, sometimes goes down, and then you don't know how much you're going to spend at the end of the month. Okay, so actually this brings us to the end of today's presentation. What about the introduction, what about the technologies of cloud computing, the advantages, and then the challenges, and also we looked at virtualization. So please, if you have any questions, you can ask me. I'll gladly answer. Hello? Hello?
Hello. Yeah, Thomas, I can hear you.
Please, if you have any question, you can ask me. I think I concluded on that. Anyone with any question? No.
Please, are there any questions that you would like Thomas to answer before we close today's session? Okay, so if there are no questions, thank you very much, Thomas. That was a pretty insightful presentation, and to all our attendees, a very big thank you. We are far behind time, so thank you all once again for joining, and we look forward to seeing you all same time next week, Wednesday, 12 noon EST and 4 p.m. GMT. So we'll meet same time next week. Have a nice evening. Goodbye.
Bye.